Good morning, everyone, and welcome to our Constromart Knowledge and Experience Series, Vol.3 number 5. Today, we are pleased to hear firsthand how to implement UAV technologies for monitoring infrastructure development projects. We are as project engineers, we all one way or another supervise works, and sometimes we wish we are everywhere when the contractor is working, but then because we are just one human being, it's so impossible to be everywhere. So today, this presentation will really enlighten us on how to be everywhere at the same time. To present this, we have with us Surveyor Rodney Tagoe. Surveyor Rodney Tagoe is a seasoned drone professional and a technology entrepreneur, driven by a passion for enhancing processes and delivering innovative solutions to the market. With a rich skill set encompassing photogrammetry, geographic information system, management, marketing, sales of unmanned aerial vehicles. Mr. Rodney is a distinguished professional member of the Ghana Institute of Surveyors. He is currently serving as the Managing Director at Dronetec Consults Limited, a rapidly growing enterprise specializing in drone services, training, and sales in Ghana, West Africa. His vision extends beyond the present, aiming to contribute to build, train, and distribute world-class unmanned aerial vehicle across Africa in the near future. You are welcome to K&E series, Mr. Tagoe, and I will leave the floor for you to start your presentation. Thank you.
Good morning. Thank you very much for a great introduction. Good morning to all our listeners, and let me share my screen so that we take it from there. Could you please allow me to share my screen from here?
Please, you can share your screen now.
Okay. All right, good morning once again. My name is Rodney Tagoe, and today we will discuss implementing UAV technology for monitoring and inspection of infrastructure projects. We'll first of all look at drones, basically, where drones have come from and the usage of drones. So drones, also known, or UAV, also known as a drone, is an aircraft with no human on board. So previously in the past, where military realized that a lot of their pilots were being killed, there were some missions that were being dangerous for some of the pilots to engage in. So there was a whole idea that we should bring an unmanned system that will be able to get us to these enemies, and we should be able to do that without losing a life. So in the 20th century, drones came about. The military was mainly used for military work. Now in the 21st century, drones have become a major asset to most military operations. So as technologies improve and costs come down, their usage has expanded into many military applications. Most relevant of them is for Earth observation. So for monitoring of their projects, monitoring of their operations, and then also surveillance of areas and all that. Unmanned aerial vehicles in recent years have been increasingly being adopted in architecture, engineering, and infrastructure industries. To satisfy the needs of various types of infrastructure projects, there has been a considerable amount of research work that has been performed to implement and refine the operations, safety, and accuracy of UAVs. Now let's look at the types of UAVs. There are 4 types of UAVs. We have the multi-rotor UAV, we have the fixed wing, the single rotor, the hybrid fixed wing. So from the image you see here, the multi-rotor are most the common ones we see often because they are cheap. Then we have the fixed wing, which flies more like the aircraft. Then we have the single rotor, which looks more like the helicopter-like type of drone. So it has only one motor up there. And then we have the hybrid fixed wing, which works both in multi-rotor mode and fixed wing mode. Let's talk about the differences between the multi-rotor and then the fixed wing. So the multi-rotor are cheap, while the fixed wing is relatively expensive. When we say multi-rotor, relatively, you could get a multi-rotor around $1,000 to $2,000. While the fixed wing can go up to about $30,000, $50,000, $100,000 and $150,000. But multi-rotors are easy to operate, whilst the fixed wing needs more experienced operators. So once someone undergoes a training for a period of 5 days or even 3 days, they can be able to control multi-rotors. Whilst the fixed wings needs more experienced operators because there are a lot of factors that need to be considered in order to perform the operations as well. Then the multi-rotor has easy and vertical landing, so it takes off vertically and lands easily. While the fixed wing has horizontal and needs sufficient space to land. So you can fly maybe a fixed wing at your compound. You need a space, maybe something like a runway or an open area where the drone can easily land should there be any case. So just like the aircrafts that land, they land on the runway. And then also the multi-rotor have short flights and low coverage. So they're able to fly for a short period of time. And then they're able also to cover only a short area, so a small area for monitoring and inspection. And the fixed wing have long flights, and then they have high coverage, so they cover a wide area, and they fly for a longer period. The multi-rotor is suitable for small area mapping, while the fixed wing is suitable for large area mapping. Then we also say the multi-rotor comply with aviation regulations because once flying a multi-rotor, you maintain what we call visual line of sight with the drone or a UAV at all times. So you're able to see your drone when you fly. But a fixed wing often needs permission to fly because you often be operating beyond visual line of sight. So you might not often be seeing the drone because of the long endurance of the drone and then the wide range at which the drone can go. Maybe a drone can go or a UAV can go all the way about 6 kilometers or 10 kilometers away from you. There's no way you are going to see the drone. So we often say you need permission to fly the fixed wing. Now let's look at some sensors that are put on board of the drone. So we have visible light sensors, which is the A part, which is often used for mapping and visual inspection tasks. We have the light detection and ranging, which often is used for 3D map or to create a 3D map of a site, also to generate terrain models for projects to go on. So let's say you go into a new area where there's a lot of vegetation and there's a need for assessments to be done, where you check the terrain to know how the terrain looks. You don't necessarily have to cut all the trees before you do that. So you can use this system to fly, and then you will be able to differentiate the ground from the trees and other features on the surface. Then also we have the thermal payloads or sensors, which are used for heat detection and heat signatures, especially for power line inspections and monitoring, also for pipeline monitoring and inspection as well, and also to locate hidden faults. And then we have the global positioning system or the real-time kinematic sensors, which are used for high accurate survey mapping purposes, and then to read hard to reach areas. Now let's look at some benefits of using UAVs for monitoring and inspections. So they are able to acquire the data much faster compared to the traditional means where maybe if I have to monitor a project in maybe Tamale, it is way faster when I use the drone than maybe a person driving all the way to Tamale to go and execute the same mission. In terms of cost, it saves cost. The number of people required to do the work is being reduced, the time is being reduced, and also it helps in efficiency. So it increases the efficiency of the works also as well, making it much faster. The safety is also reduced because you can stand at a longer point in order to do your monitoring, which is quite safer. Then you also are able to acquire high accurate data as well, or high quality data. Then let's look at some challenges and limitations of the use of drones and UAVs for monitoring and inspection of infrastructure projects. There are regulatory and legal issues which are imposed by aviation and all other governing agencies relating to the use of this system, especially with the pilot certification, with the UAV registration, the flight restrictions, and then the data privacy. So the pilot certifications, mostly the pilots need to be licensed by the aviation authority of the country in which the operator has been working in. Then mostly also, once you buy a drone or you acquire a drone or a UAV, you need to register it with your aviation authority. There are also flight restrictions, which has to do with the no-flight zones. So there are areas which are restricted to flying, especially areas closer, 10-kilometer radius from the airport. No one is supposed to fly a drone in that area without authorization. In terms of data privacy as well. Then let's look at some technical limitations. Most of the technical limitations of the drone are the limited flight time. So mostly you might have to do some inspection and the battery life is not enough to cover that mission for you, meaning that you need to have a lot of batteries in order to do your inspection and monitoring of your project. And also there's limited range. So hopefully maybe you want to fly for a distance of about 20 kilometers. There's sometimes this limitation in terms of the range at which these UAVs can fly up to. Then the camera resolution, then the sensor accuracy, and then the data processing capabilities of the drone, and then the computer systems you use. Also, when we look at the data processing challenges, there's issues with managing data. Once you keep on, the project is ongoing, there is more data that is being acquired from the field. So managing the data becomes quite difficult when you don't really have a system to be able to hold the data well. Because once you lose data, it becomes difficult to get by with it. So there are some challenges with regards to managing data. Then there's data accuracy and inconsistency as well, for data to be accurate and consistent. Because you might be flying different projects at different locations. There is that form of sometimes inconsistency in the data and the accuracy. Sometimes there may be an area you might fly very higher. So it increases the GSD of the data set. So let's say I'm flying an area somewhere in Accra for monitoring and inspection, and then I move to Kwehu to do a similar work. Sometimes because of the terrain there, how mountainous the place is, my flying height may change. So there's this kind of inconsistency in the data sets you will get based on the location the work is going on. And also data interpretation also has to do with the professionals who do the work of monitoring and inspection, where companies need to invest into their human capital or their employees in order for them to be able to understand and interpret the data much better so that they can get the best out of the data they've acquired from site and projects. So why infrastructure monitoring and inspection? Infrastructure monitoring and inspection is a process of examining and evaluating various components of critical infrastructure, such as roads, bridges, power lines, and buildings, to identify potential issues or problems. The primary goal of infrastructure inspection is to ensure that the infrastructure is operating safely, efficiently, and effectively. Infrastructure monitoring and inspection involves a range of activities. First, you need to do your visual inspections, then asset management, and then data collection. During an inspection, various factors such as the structural integrity, wear and tear, corrosion, and other potential risks are evaluated. The results from infrastructure monitoring inspections are used to determine overall condition of infrastructure, identify areas that require maintenance or repairs, and prioritize maintenance activities. So some of the results are used to mainly prioritize maintenance activities, how maintenance is going to be carried out, also to identify areas that require maintenance and repairs. This information is also used to plan for future infrastructure improvements and upgrades to meet the changing needs of communities. Also, infrastructure monitoring and inspections are critical to ensuring that infrastructure systems are functioning at optimal levels and to identify potential hazards before they become major issues. So there's this form of monitoring, ongoing monitoring, which has to go on in order to identify. It helps us identify issues. So once there's a project going on, it's an infrastructure project or maybe a 16-floor story building is being constructed, there need to be some ongoing monitoring with these systems, which helps us to be able to find out issues or hazards that may be present and identify them quickly. Then we'll be able to tackle them as soon as possible before they become major issues. Then effective monitoring and inspection help to prevent accidents and ensure that the infrastructure systems continue to operate efficiently and effectively. UAV drone monitoring enables infrastructure managers to capture highly detailed data and images that can provide critical insights for maintenance planning, documentation, and make decisions. The data collected by drones or UAVs can be used to create highly accurate 3D models, which can be used to identify structural issues or other potential problems. This information allows asset managers to make more informed decisions about maintenance priorities, budgets, and timelines. So what drones can be used for monitoring and inspections? So as we mentioned earlier, there are 4 types of drones, but let's look at mostly the drones that can be used for monitoring and inspection. So mostly we use the multi-rotor drones are most used for monitoring and inspections. So these drones are typically used for inspections of buildings, bridges, telecommunication equipment, and other structures. Then also we have the fixed-wing drones. Some few fixed-wing drones are also used for large area infrastructure systems, such as pipelines or power lines. So let's say there's this high tension, it's more prevalent, more better to use the fixed-wing drones. There's this, I learned ECG have acquired fixed-wing drones, which they are using for inspection and monitoring of the high tensions. I think they bought over 15 of them. So for long range, then the fixed-wing comes in. But for small area where we do maybe a small area where the project goes on, then there's the need to use a multi-rotor. Then we have the dock-based drones. So the dock-based drones is just that it's also known as a drone-in-box solution. So what it does is that it's an automated system which may have a multi-rotor in there. What it does is that once you do your monitoring, it helps you do more automated type of monitoring. So in the initial stages, you have to do the work by yourself, and then the data is being saved into a system. Then with that, you can be doing ongoing monitoring and inspection of your projects without you necessarily going there. So it comes back once it's done doing the monitoring. It lands in this dock and closes. The dock charges the system, and through the dock, connecting the dock to your system, your computer system, you can be able to download all data sets and any information you need from the drone. So it's a more of a new technology, the technological way of doing monitoring and inspection, which came by I think somewhere last year. So it's a specialized piece of hardware designed to support the operations of drone. So then let's look at the future of UAV's infrastructure. In the future, we are looking at increased range and endurance. So meaning there will be more drones that could fly for a very long period of time. We will have multi-rotors that could do longer hours compared to where they do now. So that is things we are looking out for as the technology evolves. Then there will be improved sensors and cameras. There will be cameras that could zoom up to about 100 times, which can do more monitoring at a far distance, a further distance. And then there will be multiple drone missions as well. So once there's a particular infrastructure we would like to do our monitoring and inspection of, we can deploy about 5 drones to do similar work. So once there's this infrastructure, these drones can fly at various vantage points that are able to acquire data sets for us at various sites. And then we'll be able to analyze and interpret this data to be used for planning and then also maintenance purposes. The use of artificial intelligence and machine learning will come in more to improve upon the activities of drones and UAVs in the system. There will be cloud-based data management systems. Currently, some have cloud-based, but only few people are using them because the technology is still evolving. And then integration with ground-based sensing as well, where we have some ground stations that will be able to coordinate the use of the drones in the air. And in conclusion, drone infrastructure monitoring inspections are changing the way infrastructure projects are managed by providing more efficient, cost-effective, safer, and detailed way of monitoring and inspecting critical infrastructure. As this technology continues to evolve, we can expect to see even more benefits and opportunities for infrastructure managers to improve safety, efficiency, and reduce costs. Thank you.
Thank you so much, Rodney Tagoe, for the wonderful presentation. I must say I have learned a lot about drones today, and I believe that going forward, we will even more involve that in our work. I know that our firm currently deploy drones for surveys and other site activity, but then I hope that we will adopt it and make our work efficient and easier. So please, the floor is now open for questions. So if you do have any questions, feel free to raise your hand by clicking on the raise your hand button. Then you'll be called to ask. I can see Daniel Johnson's hand is already up. Daniel, please go ahead and ask your question.
Okay, good morning, and thank you for the very insightful presentation. My question is about using UAVs for monitoring of infrastructure projects. Would you need a software to help monitor infrastructure projects, or you can just base on the UAV drone feed to monitor infrastructure projects? Thank you.
Okay, thank you, Daniel, for your question. Yes, you need softwares to also do that as well. You know, there are visual inspections. So as I said from the presentation, the inspection house stages where we have the visual inspection, and then when you're also looking at the asset management aspect. So the visual inspections, you have to do them manually yourself, where still there's a software medium that is being used in order to acquire those data sets and information. Then we have the aspect where there is a program kind of software where you input the details and the type of things you want to look out for. Especially maybe if you are using something like a thermal camera, there are some details you can put in there to pre-plan the activity before the UAV is being used. So there are some softwares that can be used, that are being used. So most of the software, we have the software that are being used for the acquisition of the data. And then there are softwares that are also used for the analysis of the data as well.
All right. Thank you. I believe, Daniel, this answers your question. Please, any other question from anybody? I wanted to ask a question myself. Is it possible to tell us some of the potential environmental impacts or consideration associated with the use of UAV for infrastructure monitoring?
Yes, so some environmental, in terms of once this UAV, especially the large ones, some environmental challenges could be with dust, you know, so maybe by establishing where these systems can take off from on the sites, is something you really have to consider. Maybe having a helipad there to help you in landing and takeoff. Because mostly on an infrastructure project site, there may be sand and stones and all that. So you are looking at an area which is free of all that. That will prevent the dust aspects of, from spreading and causing harm to people.
Okay. Thank you very much, Xavier. Please, is there any other question from anybody from the audience? Well, also, I believe there are some trainings or expertise that is required to even fly a drone. Are you able to tell us what you need to do to become a drone pilot, and are there any regulations or licensing processes that anyone needs to go through to obtain before they can fly a drone?
Yes, so there are three types of areas where you look at drones. We have drones, people who are flying drones for recreational purposes. We have people who are flying drones for private purposes, and we have drones who are flying drones for commercial purposes. Now, when you fly a drone for both private and recreational, you don't necessarily need license. Now, currently, they have what we call the safety exams. So once you buy a drone, maybe as a private company, you can register the drone as a private owner of the company. Now, there may be projects this company is undertaking and is using a drone to acquire or to be able to monitor their projects. Now, you could register this drone as a private owner, which you don't necessarily need a license to fly. All you need is to engage in a training and also have the safety exam written on the aviation website. Then the second aspect is where if you want to use the drones for commercial, or you are looking at getting a license so that you could get a job or offer services, then you need to go for a training. I think currently it's only UMAT who does the certified aviation training, which lasts for 2 weeks. Once you are done, you submit your certificate to the Ghana Civil Aviation Authority, and then you will pay to write the exams. Once you pass the exams, you'll be asked to do a class 3 medical examination. And then after the medical examination, everything is fine. If your visuals are good, they will do ECG and various other tests they will do. And then after that, you do what we call a skill test. So the type of drone you are looking at using for your operation, you will be tested based on that to see whether you could use the drone or you can't use the drone. Once you'll be able to meet all these requirements, you'll be issued a license for a period of 5 years, which is subjected to renewal every year.
Okay. And also, as you mentioned license, in what context do you need to request for a license before you fly in a particular area? Because I remember an instance, there was a request that you can't fly in this area. You are required to ask for permission or get a license before.
So there are some areas which are no-fly zones. So we have some areas that have, especially the airport areas. So per the regulations, at a radius of about 10 kilometers from an airport or helipad with operational control, it is not allowed to fly a drone 10 kilometers away from the airport. So for you to fly, you need to have permission or authorization from aviation. Currently, some of the drones allows you to unlock whilst you're on site. So you key in your name, your information such as your number, your email, and then a code will be sent to you, which you will use that to unlock that zone in order to fly.
Right.
Also, you may not necessarily need a license to fly in this zone. All you need is mostly the drone must be registered. Once the drone is registered, it updates your chances of getting permission to fly in some certain zones. Because they may not necessarily ask for your license number to unlock. They mostly ask for your information, such as your name, your number, and then that information is being entered into the system, such that if there's any issue, you will be contacted.
Right. I can see that Mr. Kofi Yaboakwan's hand is up. Mr. Kofi, you can go ahead and ask your question.
Okay, so please, can you hear me?
Yes, we can hear you.
So my question is, what about fabulous operations in Ghana? How do we go about fabulous operations in Ghana?
Kofi, can you come again with your question? Or talk a bit louder. I didn't hear you.
Question is, with fabulous operations, let's say fixed wing and the hybrid operations, how do you go about them?
Yes, so BVLOS operations, you need to get certification from aviation. You need to be allowed to be able to conduct beyond visual line of sight operations. Currently, I know some few companies have that BVLOS kind of certification. One, there are some kind of criteria you have to meet in order to do BVLOS operations. You must have a system to be able to detect and avoid any obstacles or traffic in the air. And also, hopefully, they would have to put you in a segregated airspace where most of the activities of the main aircrafts don't often use those parts. So those are some considerations they will look at before they allow for BVLOS operations. Currently, some companies are using drones for surveillance of their concessions. And as part of the requirements, they need to go for national security clearance. They need to get a BVLOS certification as well. And those were some of the few things that were looked at in order for them to operate that, because they will be operating beyond visual line of sight. So just like example is Zipline. Zipline is doing most of the BVLOS operations, where they have a means to be able to detect and avoid traffics in the air. They're able to communicate with the tower at aviation and all that. I think moving forward, that is where most of our activities will be moving to, where drones will be used for high beyond visual line of sight operations. But it's quite on the low now, but it needs a lot of criteria need to be met in order for you to be allowed to use that system.
Okay, thank you so much. Kofi, I hope this has answered your question. Engineer Surveyor Isaac, so you may go ahead to ask your question.
Thank you. I must commend this Surveyor Tagoe for this tremendous work you've been doing all this while. My question is on certification. You made mention that before you get certified, the intended drone needs to be, you need to do your skill test with that particular drone. Now,
Yes.
if I'm tested with, let's say, Phantom 4, and I've been certified or licensed to use Phantom 4, then after a period of time, maybe less than the 5 years, I changed my drone to maybe a fixed wing or another drone. Do I need to go back to GCAA for certification to use that particular drone, or the earlier license permits me to use that drone?
Okay, thank you, Isaac. So yes, you need to go back to aviation in order to update your license. So once you get your license, there will be the stated type of drones you are being limited to use. So currently, if you are being trained or you went for training and you did training with Phantom 4 and you are being licensed with them, you will see at the back of your license that you have Phantom 4, and then they said there's other remote control, visual line of sight operation, meaning that any other drone that falls within those sites, which has to do with the visual line of sight operation drones, you can still operate, especially with a multi-rotor. So they will actually, they'll just take there that multi-rotor visual line of sight, meaning that once you have, maybe you've done the training with a Phantom, but you can still use a Mavic, you can still use a Matrix. based on the weight of the drone as well. But once you move into fixed wing, you might have to go back to aviation, and then they'll just add that aspect to you. So you might not go through the whole process again of going through training again. No, medicals, you won't do medicals again. You've already written your exam. So the only thing they will do again is to do a skill test for you again to find out whether the new drone you are saying you want to operate, can you be able to operate it? Once you're able to execute that, they will add that to your license and create a new one for you. So there are some people who have a lot of drones they can fly, or they've been certified under. They did skill tests on almost all the type of drone. I met a friend of mine, they are into the sales of drone, and he has different types of drone under his license. So he has the Mavic, he has the Matrix, he has the Phantom, and then there's this agricultural drone and other drones also stated there. Yeah.
Thank you.
Okay, thank you. Thank you, Engineer Tagoe. Please, there is a question in the chat box from Irene Yeboah. She says, thank you for the awesome presentation, Mr. Tagoe. Please, what is the farthest distance one can go in terms of using the UAV for monitoring purposes?
So with the farthest distance is relative to the type of system you are using. So we have drones that can go up to 8 kilometers. Some can go 15 kilometers. We even have some that can go up to 60 kilometers. So for monitoring and surveillance purposes, we have drones that can go way longer. Recently, we had a training at one of these companies where they bought a system that can go up to 60 kilometers. So I think we tried about 20 kilometers, it worked. Sometimes the companies manufacture these drones and they state the range, but once you test it on site, there are a lot of conditions that may not allow you to reach those. But the farthest, you could go up to 30 kilometers, which per my experience, we have done, and but they can actually have more that can go and do more inspections for you.
All right. Thank you so much. There's also another question from Salma. He also says, great presentation. Please, what safety measures should be taken into consideration when operating drones in the populated areas?
Yes, so one of the safety measures you have to look at is, per the regulations, you are not supposed to fly drones over populated areas of the cities or an open air assembly of persons. But it can be operated at such a height as will allow when landing is to be made without undue hazard to people present in the environment. So let's say those who use drones for maybe wedding photography and those things, you need to fly at such a height or a distance that would prevent you from maybe causing harm to people in the environment. And then also, you are not supposed to fly people's buildings or people's properties, not under your watch, at a height of 30 meters. So if you are beyond the 30, it's safer. But once you are within the 30, you are obstructing, you don't have permission to fly people's buildings and people's properties. So those are some of the safety measures you have to look at. Make sure you don't fly 30 meters of people, because somebody can shoot your drone or bring down your drone based on you coming that low to their premises without their permission. So look at the 30 meters, don't fly 10-kilometer radius from the airport or helipad. You are being allowed to fly 400 meters above ground level or 120 meters above ground level. So once you are flying within an airport zone or you are flying within an area where drones, where the aircraft pass often, you must avoid those things. So your 10-kilometer radius are things you must remember. Your 400 meters or 400 feet above ground level or 120 meters above ground level, you have to look at that as well. You have to look at 30 meters from people's building, which are not under your watch. And you must not fly your drone over open air assembly of persons. You know, when there are a lot of people seated and people are like, do ring delivery, you must fly at such a height or fly at a safer side, which makes your work much safer.
Right. Thank you. I believe Salma and Irene, your questions have been exhausted here.
Yes,
So
please.
please, just as you mentioned, there was a question on the safety. What are some of the typical accidents that has occurred in using drone?
Yeah, so the typical accidents has to do with crash, a drone flying into a tree, where sometimes you look at the battery, because of how expensive sometimes the battery is. When the battery gets swollen, the batteries of these drones get swollen, people often tend to not stop using it. So they keep on flying, and sometimes it causes the drone to fall from the air because the battery strength is not that good. And then also people fly into people's buildings and then trees as well. Also, there's this bird strike where birds can also attack your drone and then it may fall. And then also, once a person is not trained to do the works, sometimes somebody will decide to fly his drone in a room. So in the room, once you take off, you may crash into the wall. So those are some things that could lead to accidents or incidents for your drone.
Right. Okay, so what about to people? For example, if you are flying in a populated area, what harm can it cause to people?
Yeah, so for generally people, it may not necessarily cause harm unless you fly very close to them. Then it's not safer. You can cut them. But aside that, you need to, for the drone, is for aerial shots. It's not for close range photogrammetry. There's this type of photogrammetry where we have the close range photogrammetry, and we're looking at what we call the aerial photogrammetry, where aerial has to do is airborne. So the drone is in the air. It doesn't necessarily have to come very close to people as compared to the camera, which has to come very close to people for you to get visuals or get monitoring data.
All right. Okay. Thank you so much. Please, are there any other questions? If not, we would wrap up here. Okay, so I see there are no other questions. So thank you so much, Surveyor Rodney Tagoe, for taking time of your busy schedule to be with us here. I must say I've learned a lot about drones, and I know that going forward, I could also be able to fly one myself. Thank you everybody for joining in today's session, and thank you for your contribution. You made the session very engaging and very successful. Thank you so much.
You're welcome. Thank you too.
Have a great day,
Bye.
everybody. Bye.
Okay, bye.